Today we're doing linear equations and rational expressions 1.2, day 2 and 3. Our learning goal is for you to be able to recognize identities, conditional equations, and inconsistent equations. Before we do that, I want to review rational equations with variables in the denominator. So let's do one where you have to factor. Okay, remember the previous lesson, you want to find out what your common denominator is. So I'm going to have to factor this one in order to figure it out. So it'll be x plus 3, x minus 2. So I'm going to multiply each of my fractions by that. And the reason why we're doing this is so that we can get rid of the denominators. So here, x plus 3 cancels out, and you're left with x minus 2 times 6. Here, x minus 2 cancels out, and you're left with x plus 3 times 5. And then here, both factors cancel out, and you're left with negative 20. Now you just distribute. Okay, so now you just distribute. You'll get 6x minus 12. Be careful with those negatives. Minus x minus 3. Excuse me. This one we have to do with the 5. So it'll be minus 5x minus 15 equals negative 20. And then you combine like terms. So I get x minus 27 equals negative 20. So x equals 7. And don't forget, which I did, to do your restrictions. X cannot equal negative 3 or 2. So as long as we don't get those as solutions, we're okay. But if you do get one of your restrictions as solutions, then you have to write no solution. Okay, here's an equation where they want us to find all values of x such that y equals 0. And here's my equation. Which means if they want y to be 0, sometimes they'll want it to be 0, sometimes they'll give another condition, but whatever they use, that's what you have to do. So I'm going to subtract the 7/5 over. Sorry about that. And then I'm going to factor So I'll know what my common denominator is. So my common denominator will be 5 times x minus 1. So that's what I'm going to multiply everything by. Or x plus 1. Okay, and then the 5's cancel here. And I'm left with negative 7 times x plus 1. Everything cancels here, so I'm just left with 1. X plus 1 cancels here, so I'm left with 3 times 5. And here the 5's cancel, I'm left with 7 times x plus 1. Alright, just a reminder, our restrictions are x cannot equal negative 1. So I'm going to distribute the negative 7, make this 15, and I'm going to distribute the 7. And then I'll just combine like terms. So I get 1 minus 15 is negative 14, plus 7 is negative 7. Add 7, I'm going to get 0 equals 0. Anytime this happens, this is called an identity. That means that any number can work, or we could use any number to plug in for x. Here's our next equation. We get 10x equals 9x, so subtracting x equals 0. This is an example of a conditional, because we actually got an answer for x. So this is a conditional equation, because that means x equals 0 if, or is based upon what the equation is. Okay, this example, our common denominator is x minus 3. So I'm going to multiply everything by x minus 3. And here, everything cancels, so we're left with 3. Here, everything cancels, and we're left with x. And this one we just distribute. So I'm going to add the 9. So x equals 3. Don't forget to do your exclusion was x cannot equal 3. So because this happened, it's no solution. And anytime you get a no solution equation, that means that this is inconsistent. So we have inconsistent, where everything comes out to be true, conditional, where you actually get a value for x, and inconsistent, no solution. This is a summary of the types of equations. Identity means both sides are equal. That means this equation is true for all real numbers. Conditional means you are going to get a solution, which will mean you'll get a real number solution. And inconsistent means you get no solution. That means a false equation. And that means no real numbers will actually work. And those are the 3 types. Oh, another example of a inconsistent is a false statement. Like 0 equals 7. That's not true, so that's one. And we're done.